Solving systems of linear equations using substitution, lesson 10 notes. Example number 1. Before we complete example number 1, I'd like you to pause your video and I want you to write down what I'm about to highlight at the top of the paper here. So right above example 1, write that down. Pause your video and do so. All right, so it says, for the last step, use the equation that resulted when first solving for a variable. What that is saying is, you're going to want to use the equation you get right here and the last step over here, which I already explained when I did the first video. So the first equation you get when you solve for a variable, that is what you want to use in the very last step. So let's look at example 1. Example 1, we've got x minus 2y equals 7 and 3x plus 4y equals negative 9. Which variable is the easiest one to solve for? Well, this has a coefficient, this one has a coefficient, this one has a coefficient, but the x doesn't. So the easiest variable to solve for is the top x. So we are going to solve for the top x and plug it into the bottom x. Solve for the top x, plug it into the bottom x. Write this down. Okay, solving for the top x means I need to add 2y to both sides of the equations. Write really small because you're going to need to fit it in between the two equations here. So that would cancel, bring down the x. Remember, these are not like terms, so I can't combine them. I bring down the positive 2y, and I bring down the positive 7. All right. Now, use different color. So this expression is going to sub in for the bottom x. We solved for the top x, and now that's going to sub into the bottom x, which will look like this. So I've got, instead of 3x plus 4y equals negative 9, I've got 3, and then I replace the x with the 2y plus 7, and then I have plus 4y equals negative 9. All right. Starting with the distributive property. So 3 times 2y would give me 6y. 3 times 7 is 21. Bring down the 4y, keep the equal signs lined up, bring down the negative 9. For like terms, I have positive 6y here and positive 4y here. And then everything else, so that doesn't have a like term, and this is by itself, so it doesn't have a like term. So 6 plus 4 would give me 10y. Bring down the 21, bring down the negative 9. And now this is a two-step equation. I have one variable term on the left, so that means I need to take my constant term to the right. Since it's positive 21, I'm going to subtract 21 from both sides. They would cancel, and you would get 10y equals negative 9 minus 21. Please be putting these in your calculator. So this would be negative 30. Last step, divide both sides by 10. They would cancel, and you would get y equals negative 3. Okay, but we're only part of the way done. We found one of the variables, now we have to find the other variable. So again, I'm going to use this equation that I solved for here. I'm going to write it down in the last column. So over here where I have highlighted, it says x equals 2y plus 7. So I write down x equals 2y plus 7. And this negative 3 is going to go in for the y. So x equals 2, put parentheses, plus 7. And I replaced the y with the negative 3. Put that on your calculator at once. 2 times negative 3 plus 7 would give you 1, because negative 6 plus 7 is 1. All right, so our final answer is x equals 1, y equals negative 3. Our final answer is x equals 1, y equals negative 3. Let's check this using the graphing calculator. Okay, so we think our solution is 1, negative 3. Pull up these two graphs. Hit the point where they intersect. They intersect at 1, negative 3. So we are correct. So that is it for example 1. If you have any questions on example 1, please let me know.